All right, let's get ready to crush your final exam Monday, right? So number one, we've got a function f of x, which is equal to 5 over x minus 1 times x plus 4. Do you remember these? No? I don't know. So we're asked to find the y-intercept, the horizontal asymptote, and any vertical asymptotes. So the y-intercept, wherever the heck this function crosses the y-axis, what do you have to do to find the y-intercept? What does x have to be if
0.
this is right? And if you're crossing the y-axis, obviously x has to be 0. So all you do is just plug in 0 for x. And what do you get?
Negative 1 and 4. And
Right,
you
in the
multiply
bottom.
them together, you
Yes.
have negative 5 over 4.
5 over negative 4, which is obviously negative 5 over 4. Yeah. So the y-intercept is just going to be at the point, right, when x is 0. So 0, negative 5 fourths. All right. Do you remember at all how to find asymptotes?
You gotta redefine that, right?
Yeah. So that's like where you blow. Well, the vertical asymptote is where you blow up, basically, and it's where the function is undefined. But and the horizontal asymptote is we have those rules. Basically, it's the end behavior. So the end behavior basically as x gets really big, what does the function like approach something? As x gets really big, something huge minus 1 is still really huge, right? And something huge plus 4 is huge, right? So it's like if x is infinity, infinity minus 1 is still ridiculous, right? Big. And then infinity plus 4 is still huge, so you just basically get 5 over something really big. So basically if you get like 5 over something huge, if the bottom gets really big, what happens to the whole fraction?
It gets really small.
It goes to 0. So I guess it was if the degree of the bottom was bigger than the degree of the top, you have a horizontal asymptote, which is just going to be the x-axis, which is the same thing as y equals 0. So you've got a horizontal asymptote at y is equal to 0, and you have the vertical asymptotes at the vertical asymptotes is just where the function blows up. That's where you're undefined. So this look, you have a rational function, a fraction, right? You're undefined when the bottom is 0, right?
I was gonna say that
Yeah.
we know the horizontal asymptote is 0 because it was bottom heavy. If we solved it like x minus 1 times x plus 4, getting x squared plus 3x minus 1.
If you expand it out, yeah.
Yeah, since it's bottom heavy, then it would basically mean 0 for
Yeah.
the asymptote. Okay.
Yeah.
Okay.
And vertical is where you blow up. So it's where you're undefined, just looking at it. You're multiplying two things in the bottom, right? So if either one of the factors is 0, the whole thing's going to be 0, right? So you could expand it out. Why? I mean, just look at it. What values of x make the bottom 0?
It was 1.
1 and negative 4, right? Yeah. So it's just going to be, it's always like it's x equals, because it's a vertical line, so x equals 1 and x equals negative 4 are the vertical axes.
Okay, I have that right.
We've done this it's been a minute. Yeah, so that's probably the extent of what you'll see as far as rational functions, so if you understand that, you should crush that. Question? And then we jump into some log questions that you should just look at those and, right? These are hard, we got time. So number 2, we got ln of x, natural log.
Hang on.
Yeah.
So with the vertical asymptote, it's just whatever gets that back to 0? On the denominator?
The vertical asymptote is basically, yeah, when the denominator in the bottom of a fraction is 0. Yeah. You're undefined, and then the function's gonna blow up there.
And then the vertical asymptote with y equals 0, that's just because, as the fraction gets bigger, it gets closer to 0? I don't understand that.
Yes, it's so basically, so the horizontal asymptote, it gives you the end behavior, in a sense, it's the limit as x goes to infinity. We haven't even talked about limits yet, you can see that in calculus. But as x gets really, really big, this is 5 over, it's basically 5 over infinity, right? As x gets huge. And something over infinity is like, goes to 0, right? If you look at like 1 over a huge number, it gets really, 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 it's always gonna be positive, but it gets as small as you want, it approaches 0. So, and if the degree, remember degree is the highest exponent
Yeah.
of the bottom is bigger than the degree of the top, it's just going to be, the horizontal asymptote is going to be the x-axis, which is y equals 0.
Alright, well, wait, say that one more time.
If the degree of the numerator, so we had those rows, I mean, we had if the degree of the top was bigger than the degree of the bottom, there was no horizontal asymptote. Unless it was only one bigger, and then you have slant asymptote, which might not see that. But if the bottom, the degree of the bottom was bigger than the degree of the top, then you had a asymptote there at the x-axis, which is y equals 0. And if they were exactly the same, then it was the ratio of the leading coefficients.
Yeah, I was just playing this thing,
But, yeah. But, logs, you feel good about logs?
No, I've done it in months.
Well, if you just had ln of 4, what is it? What's ln of x? ln of x. ln of x equals 4. And you chose to change that to exponential form.
So wait,
That, yeah.
there's like 18 or 20 questions on this. But
Yes.
you said it's gonna be 50 on the actual exam?
Did I say 50? It's going to be very similar to, I mean, to the review, right?
So,
Understand these
20
questions, I don't know the exact number of, some of these are multiple parts too, right? So, it'll be, yeah, it's a 2-hour exam, so. It'll be very, I mean, I think I took the, I made the
Okay.
exam, and then I made review questions that were just like the exam. I mean,
But, I'm not, okay, but,
yes.
if you had to estimate how many questions on an exam, what would your deal estimate?
How many questions are on here? I mean,
Like 20.
Are there 20? What's 18? But a lot of these are multiple parts, right?
Yeah, but like,
So you still, does that still count as 20 questions? Then about, yeah, 20, I would say 20 questions. Some multiple parts, so it might end up being like.
I mean, the parts don't matter, it's just the questions that.
Okay, I can make one question and just give it like 100 parts, and that's still one question.
Okay.
Okay. All right, so we don't, I mean, I want to get to the ones that are more juicy, that these should be fast, right? Or no? So if you have it, ln of x equals 4, you're told to change that into exponential form. Well, whenever you see ln, you can always write that as log base e, right? And the only sentence you gotta know to get out of any log jam you might be in, is that a log is an exponent, right? So whatever a log is equal to is the exponent you raise the base to get the argument of the log, right? So if you had something like log base 2 of 8, that is obviously equal to, well, it's saying 2 to what power is 8? 2 times 2 is 4, times 2 is 8. So log base 2 of 8 is 3, right? If you wanted to change that, you would write it as 2 to the 3rd, right? 2 to the 3rd power is 8, right? So that is just, it's log base e, which is what ln means. So it's just e to the 4th, right, is equal to x. Is that hard at all? It is, I mean, but I don't want to, you talk a lot, I mean, you gotta get some of the stuff that's a little juicy, but that's the same thing as e to the 4th. And then if you have 10 to the x, so on your calculator you have two log buttons, right? You just have ln, which is log base e, and log with nothing there is log base 10. So if you have 10 to the x equals 17, that's equivalent to saying log of 17 equals x, right?
I'm only seeing one log question on the.
That's equivalent to saying log base 10, which you don't have to write a 10, you write as log of 17, whatever it's equal to is the argument. Whatever a log is equal to is always the exponent. You raise the base 2, which is 10, to get, right, this is saying 10 to the x equals 17, same thing, right?
Could you do the last question?
Just jump. The last one, what, solving?
Log of x.
Oh.
5x minus.
Oh, yeah. We'll get, well, that one, so I made a, okay, so I made this is log, this might have been something on the exam similar to this. So log base x of 5x minus 3 over 7x plus 4 is equal to 1. This means x to the 1, which is just x, is equal to this, right? So this actually is not going to have a solution. So I would say try to solve maybe this one instead. We can do this one. So, log base x of 4x plus 2 over 2x minus 1 is equal to 1, right? Similar looking, but so if you try to solve this, you can write it as x to the 1 equals this, right? So x is equal to x to the 1, because x equals this, so it's equal to, well, 5x minus 3 over 7x plus 4, right? Solve for, and there's x's everywhere, right? Everywhere, oh my goodness. So, what you could do is you could always, if you have a fraction, you could like times the bottoms, like show the bottom of the fraction, right? So you would have, well, you could have x times 7x plus 4, right? Is equal to 5x minus 3, and then you could distribute that, right? So you'd have 7x squared, right? Plus 4x, right? Plus 4x is equal to 5x minus, and this is a quadratic. So what you can subtract 5x, add the 3, right? Equal to 0 to get what, 7x squared. 4x minus 5x is going to be negative x, right? And then plus 3, right, is equal to 0. You could now try to factor it. Good luck, you ain't gonna factor it. You could put the square, which you want to be good at. That's maybe this isn't the best. Or you could always use the quadratic formula, right? It's standard form equal to 0. You comfortable? So you have an ax squared plus bx plus c equals 0. So therefore x is equal to negative b. It's negative 1, so it'd be negative 1, so it'd be 1, plus or minus square root of b squared minus 4ac. What's b? Negative 1. So it'd be negative 1 squared, and then minus 4 times a, which is 7 times 3, all divided by 2 times a. And you get 1 plus or minus, that's going to be 1 minus, what's 1 minus 4 times 7 times 3? Now I didn't care what 4, that's going to be 8 times 7, no, 12 times 7, right? Or 28 times 3, whatever that is, doesn't matter because that's obviously bigger than 1, right? Archie, right? So it's going to be 1, it's 1 minus, this is bigger than 1, right? So I didn't mean to have this and not have a solution, but this is obviously no solution because the discriminant of the quadratic equation, the discriminant is the part under the square root. If that's negative, the square root of a negative number doesn't make much sense. It's not a real number, right? So that has no real solution. I mean, we're not doing complicated. So you can say that has no solution. This one's very similar. This one has a solution. You got this far? You want to solve that one? Right. You should be able to. It's the same as right.
Average.
Right.
Okay.
So this means, again, that if the log is base x, it means that x to the 1, but x to the 1 is x, right? So the x is equal to this, whatever this is, 4x plus 2 over 2x minus 1. You can multiply both sides by x or 2x minus 1. Say hi, not live, but we're recording. Megan's here. I'm gonna stop the car. So now we can multiply both sides by 2x minus 1, right? So get x times that would be what? X times 2x minus 1 is equal to 4x plus 2, right? So distribute, right? 2x squared minus x equals 4x plus 2. Set equal to 0 probably, right? Is this really reducing in sleep? Yeah? No. So you get 2x squared, right? Minus x minus 4x would be negative 5x, right? Negative 5x. And then you have minus 2, right? Equals 0. Is that what I have here? Yeah. Then you could hit the square if you wanted to. Or just, I mean, again, this is odd. We're going to have to practice being squared. But, or plop it into, right? And you can say x is equal to negative b. So negative 5, right? Be 5 plus or minus, what? Square root of b squared, what is it? That's negative b, yeah. Plus or minus square root b squared. B is negative 5, squared is 25, right? Minus 4 times a times c, all divided by 2 times a, which is 2. And then you get what? You get 5 plus or minus square root 25. 4 times 2 times 2, that's 8 times 2, that's 16. But that's negative 16, right? So it's minus negative 16 plus 16, right? So 25 plus 16 is 20, 30, 20, 30, 35, 41. 41? 25 plus 16. Yeah. So it'll be 25, well, so 41, right? The whole thing is 41. Right? All over 4. And then you can see it's going to be 5/4, right? Plus or minus square root of 41 fourths. Right? Oh, but then wait a minute, you're solving this, right? You can't, so obviously 5/4, well, you gotta check what this actually is. Square root of 41, which is, I mean, it's bigger than 6, well, and over 4. That's 6, that's actually, this is actually 5/4 minus square root of 41/4, that's gonna be negative. And a base of a log is not allowed to be negative. So therefore, that's actually going to be not undefined. You can actually get rid of the plus or minus and just have that as your one solution.
That's a lot. I mean, it's a lot of steps.
So yeah, that was the very last one. The one I made originally, it doesn't. I tried to have it have a solution, but it doesn't have a solution. So
Yeah.
I made another one. I made another one that was similar to that one.
Are the problems on the test gonna have solutions?
Probably, yeah. You can try, maybe not. I meant to. So we can jump, I mean, we're gonna go kind of in, we did the first page. Done.
Technically, this one solution is shorter, because after you see the negative in the square root.
We're gonna have time to get to the whole thing, so there's certain ones you wanna cover, for sure?
I would just be tweaking and being like, I didn't do this right. Like something went wrong here. Like,
Yeah, that makes sense. I
Yeah,
question
yeah.
that too.
We covered asymptotes, you feel good with, Megan? Whatever else
can you go over asymptotes one more
One more time.
Oh, is that what we did at the
Well, the
start?
y-intercept, just plug in x equals 0 and see what it evaluates to,
Yeah.
right?
Plug in y equals 0?
X, it didn't ask for x-intercepts, right? You see why it didn't ask for x-intercepts?
Because he gave us some already?
Well, no, because there are none. I could have asked for them, but you see why there are? So the x-intercepts is obviously when y is 0, right?
Yeah.
So if you have a rational function, so y is the same thing as f of x, right? So if you set f of x equal to 0, and you solve for what values of x make the output 0. So you're solving 5 over x minus 1 over, or 5 over x minus 1 times x plus 4.
Doesn't work.
When is that equal to 0?
Never.
Do you see why?
Because it's a fraction that gets closer and closer to 0, but never reaches 0.
Kinda, yeah.
Also because-
But it's a fraction, and when is a fraction equal to 0?
When the numerator is equal to
Exactly.
0. But the
And
numerator
it's 5, yeah, 5 is never 0, so. It has one. You graph this thing, put it in decimal if you want to see what it looks like. But it's gonna have a y-intercept here, it's gonna have a horizontal asymptote, 2 vertical asymptotes that it's gonna have like 3 parts, but it's never gonna touch the x-axis. B, do you wanna cover, what was it, 4, part B?
Yeah. I
Okay.
mean,
Yeah,
yeah,
okay.
wait, part A?
Yeah, part A, oh, part A is didn't do, yeah, part A should be, well, I thought it was easy, but I shouldn't say it should be, right, because I want to do things easy. But, so 4, what is 4? 4 is, 3 to the, what, x plus 2? Equals 81, right? Now, you could, so, to solve this, typically, if you're solving your variable, you're solving for x, is in the exponent, you could use logs. I mean, right, because if you take a log of both sides, the log is something to a power, the power jumps down. You don't need to do that though. Because you can just realize that, well, 81 is just 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's 3 times, so that's 3 to the 4, right? When you write it as 3 to a power equals 3 to a power, then what has to happen, right? I mean, if you have 3 to some power equals 3 to some power, some exponent, then those exponents have to be equal, right?
Okay.
So, yeah, so you just, so you write it as 3 to the x plus 2 equals, that is 3 to the 4th, and that means that x plus 2 has to equal 4, solve that.
X equals 2.
Right? Easy, right? Alright, and then B looks harder, but B, the answer might be kind of nasty, maybe. Want to talk about, just talk through B? Write it out. So, divided by 300, right, so you have 300 times e to the 3x plus 2 equals 1200. You divide by 300, well, 1200 over 300 is just 4, right? So then you have e to the 3x plus 2 equals 4. If you just ln both sides, if you take ln of e to a power, it's just a power, right? I mean, so it's just, so because ln means log base e, so log base e of e to the 3x plus 2 is saying e to what exponent is e to the 3x plus 2, well, obviously 3x plus 2. So then you just get 3x plus 2 equals ln of 4, right? You gotta get that ln both sides. And then solving for x, well, you gotta subtract 2 and divide by 3, right? You can't really do anything else to that. So you have like ln of 4 minus 2 all divided by 3. Okay? Next one a little bit more. This. Next one, wanna do it? Skip it? Log of x minus 2 plus log of x plus 4 is equal to 1. Okay. Okay. Well, did we try this one? No.
Didn't we just cancel out the log?
Oh, cancel out the.
I mean, never mind, I'm sorry.
Okay.
Wait, I did it wrong then.
Well, that's. So,
I got it.
you got it, so the main, yeah,
Don't you just, it's not the same as, no.
that's right, keep, I mean.
Never mind.
Do you want to do it? Maybe you might become TikTok famous. So, so if you have, the main properties of logs are, the big one is, well, a log is an exponent, so whatever a log is equal to is the exponent, right? You raise the base to. But then if you have a product in the argument of a log is the log of something, that's the argument. So if you're multiplying, if you have a product in the argument, that's the sum of the individual logs, right, same base. If you're dividing, you have a quotient in the argument, that's the difference of the individual logs. So if you're multiplying, you write it as a sum, you're adding. If you're dividing, you write it as a difference, subtracting. And then if you have log of something to a power, the power of the exponent can jump down as a coefficient. So here, looking at this, well, you have log base 10 of something plus log base 10 of something equals 1. So you have the sum of two logs, same base 10. So therefore, you can write it as a single log, right? It's just a product of the two arguments. But the arguments, well, are x minus 2 and x plus 4. So you write it as just one log, as log of x minus 2 times x plus 4, right? Is equal to 1. And then you could expand this out. This means that 10 to the 1 is equal to whatever this is, right? So you have, this gives you x squared, 4x minus 2x, right? So you get x squared, 4x minus plus 2x, right? And then minus 8, right? So you have log of this equals 1, right? But that means that 10 to the 1 equals this. But 10 to the 1 is 10, right? So this is equal to 10. With me there?
So you go from the first one, when you're adding them together, you can take out the log from one of them? And
You can
calculate-
have, so if you, one of the properties of log says if you have a product in the argument. So if you're multiplying in the argument, it's the sum of the individual logs, same base. So here you have a sum. You start with a sum, two logs,
and they
both
both
base
have the
10.
same base,
So
yeah.
therefore you can like combine it to one log. If you had a product, right, this is like log, this whole thing here is the argument, right? So you have a product, you're multiplying, so I can split it as the sum of two logs, right?
Right.
But, so you went backwards and you wrote it as one log, you can then expand that out, but this then means that 10 to the 1, which is 10, is equal to this, right? Because what a log is, right? Whatever a log is equal to is the exponent, you raise the base 2 to get this, but this gives you this, if you expand that out. So then the log is gone, right? Because that means that 10 to the 1, which is 10, is equal to 10. And then from there, it's just a quadratic, right? We should be really good at solving quadratics.
How did you just, oh, okay, so you multiply it across the x times
Yeah.
x and the r.
So we could solve this via quadratic formula, or complete the square. This is probably nice. So actually, if you wanted the square, the way I do it, I would think of this, I would bring all the constants to the other side. So I would add 8 to both sides. You could subtract 10 to both sides and then use the quadratic formula, if you want to, same thing. But if you add 8 to both sides, you would have x squared plus 2x is equal to 18, right? And then, keep the square. Just make sure so you all remember how to square. Make sure that the coefficient on x squared, so the a value gets in standard form, right? But the coefficient on x squared, the number in front of x squared is 1, meaning there's nothing there, it's 1, right? So the coefficient is 1. If it wasn't 1, you would factor out whatever that leading coefficient is on x squared, right? But here it's 1, so therefore you can just write this again as x squared plus 2x, and then you want to add something to create 3 terms that'll factor as something squared. And how you can do that is taking half of the coefficient now on the linear term. So half of the number in front of x, half of 2 is 1, right? 1 squared is 1, right? So you add 1. Okay. To get the 1, I took half of that and I squared it, right? And that's equal to still 18, but I added something to one side, so I better add the same thing to both sides, right? Now, if that wasn't 1, you gotta be careful and account for what you add is still the same thing, but it's gonna look different, right? It's not gonna, because you gotta account for, this really is 1, but it wouldn't be if there was something up front. But here, now this factors x plus 1 times x plus 1. It always factors as whatever half of the number in front of x was, right? So half of 2 is 1. Whatever that, it's always going to be x plus that or x minus that squared. And it's the same sign, so it's plus. So it's going to be x plus 1 times x plus 1, which is x plus 1 squared, right? Is equal to 19. And then, so the vertex form, you can just bring back the constant. So that's, you should also know how to do the vertex form. Remember that, Archie? So it would so if I bring the 19 back over, I have x plus 1 squared minus 19. And that's the form a times x minus h squared plus k. If it's in that form, h comma k is the vertex. So the vertex is actually -1, -19. So because it's always x minus h, right? So the vertex is gonna be somewhere down, -1, somewhere way down, somewhere in the third quadrant. And the a value is 1, which is positive, and it goes up, and I can see therefore it's gonna have roots, and it has x-intercepts, right? And to find those x-intercepts, you solve for x, right? You find the values of x that make the output 0. And so to do that, you do the same steps to here, now we're solving it. So we want to square root both sides, right? To kill off the square. And so the square root of something squared is whatever that something is. So we're just gonna be x plus 1, right? Is always equal to plus or minus always the square root of whatever that is. And then just subtract 1 and you have x. So x is equal to, can we still see? I can still see it down here. So x is equal to -1, right? Plus or minus the square root of 19. So there's two solutions to that parabola. Oh, we're not solving for a parabola, right? We're solving a lot of equations. I forgot, right? Didn't quite get it. But, so we're solving this, right? And remember that the argument of log can't be negative, right? It doesn't make much sense, because, right? 10 to any power is never negative. So you can't have a negative in the argument of a log. So therefore, well, -1 minus root 19 is positive. So -1 minus square root of 19 is obviously negative, right? And so to subtract 2 from that, you obviously get something negative here. That's going to be undefined when it's going to be, right, -1. And -1, well, plus square root of 19. Well, square root of 19, that's bigger than 1. That's bigger than 4. Because square root of 16 is 4, right? So -1 plus the square root of 19, that's positive, and -2 is still going to be okay. That's bigger than 4. So -2, still positive. We're all good. So therefore, the only solution to get rid of the negative, right? But you in general, right? You get the two solutions, right? Plus or minus, we square both sides. But you're solving the log equation, therefore you only get one solution, which would be -1 plus or square root of 19 minus 1. Good, questions? All right, moving forward, solving exactly, I mean, we do solve, concentrate, right? So cosine of 5 pi over 3, it says exactly. So this one, well, you could probably you gotta have a calculator, right? You could put that in the calculator and it probably give you the exact right answer. But typically, so the next one, it won't though, right? Because you got pi in the answer, it's not, your decimal is not exact. So, but none of these you should need a calculator for. So, aren't you? Hey. So, so cosine of 5 pi over 3. You think where 5 pi over 3 is?
Yeah, that's just pi over 3.
Oh
No, it's not. It's 1 before.
It's 1 before all the way around. Because 6 pi over 3 would be 2 pi, right?
So would it be negative pi over 3? So would that be?
It would be negative pi over 3. Same. That's the same thing as negative pi over 3, right? Because you're.
So would the cosine be negative 1/2?
Well, so is it, what quadrant are you in?
You're in the fourth quadrant?
Yeah, right? So cosine of 1 pi over 3, 2 pi over 3, 3 pi over 3 is pi, 4 pi over 3, 5 pi over 3, and then 6 pi over 3 brings you back. So 5 pi over 3 in this fourth quadrant is cosine, so it's cosine either x or your y on the unit circle.
Cosine is the y. Or the x is the horizontal.
And is x positive or negative in this quadrant?
Negative. Oh no, it's positive.
Positive, right? What do you think? Or all students study calculus where C it's positive. But yeah, so cosine is positive, so therefore cosine of 5 pi over 3 is gonna be the same as cosine of pi over 3. Well, the same reference because pi over 3 gets you back to the x-axis, right?
How does all students take calculus tell you what's positive and negative?
Well, if you think, so all ASTC, all is positive. Because, so cosine is your x,
yeah, I'll get that, but how does all
and
tell you?
sine is
how
your
does
y.
all tell you that's positive?
so, well, all, that means all, so sine is positive, so the main trig functions are
they're
sine,
all
cosine,
positive.
and
I
tangent.
see, I get
And then the reciprocals, but those would be the same sign as the, yeah, so sine, cosine, and tangent. Well, sine is positive, cosine is
They're all
positive, x,
positive.
and therefore tangent's positive, yeah. This just sine, right? Because your y, your x is negative, and your y is positive, so sine,
Then
your
just
y.
tangent, then just cosine.
Just tangent, because x and y are both negative, So therefore tangent, negative over negative is positive, and just cosine, yeah. It's positive.
Alright.
So cosine of pi over 3, you wanted to use the hand trick. What's the hand trick? So if you think about the angles that you gotta know, right? That was 0, pi over 6, pi over 4, pi over 3, and pi over 2. Just put down whatever angle you want. So you want cosine of pi over 3, or 5 pi over 3, same as pi over 3. The sign might be different, but it's not different, right? Because in the fourth quadrant, where cosine is positive, so therefore cosine of 5 pi over 3 is exactly the same as cosine of pi over 3. And pi over 3 is 0, pi over 6, pi over 4, pi over 3. And if you read it, it's just sine cosine. So sine of pi over 3 is going to be, it's always square root of how many fingers are up. It's everything over 2. So square root of 3 over 2 for sine. But cosine, going back this way, is going to be square root of 1 over 2. Square root of 1 is just 1, so yeah, 1/2, right? So it's 1/2, right? So you put that in the calculator, you actually probably get the right answer, if I say 0.5, which would be exact. But the next one is, what's the next one? Sine inverse of 1/2. That's the, okay. So sine inverse, put it right here. Sine inverse of 1/2. So what is, so sine inverse, again, the negative 1 exponent is not really an exponent. You read it as sine inverse. But sine inverse of 1/2 means the angle whose sine is 1/2. So you could use the same trick on your hand. If you want 1/2, you want this angle, right? Because you want sine would be 1 over 2. So what angle is this angle? Well, it would be 0 pi over 6. And how about secant of pi over 3? Archie?
Secant of pi over 3?
Yeah. So how do you find secant of pi over 3?
Secant, isn't that just the opposite of sine?
It's opposite of
Cosine
cosine.
opposite.
Oh,
it's
cosecant
the,
is the
it's the upside, it's the reciprocal, right?
So you just flipped it.
Of cosine, yeah. So what is cosine of pi over 3?
Cosine of
Pi over 3. What
3.
angle is pi over 3?
That's gonna be,
Pi over
3
6
over
so
2.
pi over 3. Are you sure? Cosine? Cosine. What angle?
Oh,
cosine, going back, yeah. So cosine is square root of 1 over 2, 1/2. So therefore, what is secant of, it'd be 2, right? So secant of pi over 3, right, is just 1 over 1/2, which is 2 together.
On what?
All right. So we skip around. We have a whole lot of time here, right? Which ones have you tried a lot more? The ones you really want to try? Anyone? Erase. Get them all. The polar stuff we did that recently. There's the law of cosines. Next we have giving your sign, find all the other ones, right?
Fourth question.
That's number 6. Want to do number 6 or? Number 7, I think number 7 I made a TikTok on. But number 6? Number 6 is what you're told here that sine of theta is going to be negative 4/5. And you also know that tangent of theta is positive, right? Greater than 0. You want to find cosine, tangent, cosecant, secant, and cotangent, right? Well, you know the big identity is that, right, sine squared of any angle plus cosine squared of any angle is equal to 1. So therefore, I mean, just once you find cosine, you can find everything else, right? Sine over cosine is tangent. So since tangent is greater than 0, what do you know about cosine? That it has to be negative, right? If sine's negative and tangent's positive, that means cosine has to be negative. So sine of theta is negative 4/5. So you know that if you set it up like, you know, so you say x to cosine, so x squared plus y squared plus negative 4/5. Right? Squared is equal to 1, so you got x squared plus what? 16/25, right? Is equal to 1. Subtract 16/25, so 25/25 minus 16/25 is 25 minus 16 is that 9? No idea. 9? 25 minus 25/25 minus 16/25. Is that 900? 16, 20, yeah, 9, right? So the x squared is equal to 25/25 minus 6, that'd be 9/25. Right? So therefore x is equal to, well, technically it's plus or minus the square root of that, right? Which is 3/5. But x is going to be your cosine, and given that tangent's positive, you know that the cosine has to be negative, right? So it's not so plus or minus, but therefore cosine has to be negative 3/5. So if sine is negative 4/5, you get that cosine of theta is going to be negative 3/5, right? And then from there, you know the rest, right? What's tangent? That's going to be negative 4/5 over negative 3/5, right? Which is, right? The tangent would be sine of the cosine, so sine is negative 4/5 over cosine, which is negative 3/5. Divide by a fraction, so that's negative 4/5 times negative 5/3, right? 5, that's positive 4/3, right? And then the rest, I mean, cosecant, secant, are going to have the same sign. So obviously, if sine is negative and cosine is negative, cosecant is reciprocal of the opposite of what you would think. Right? There's only one co in the pair of the function and the co-function. So tangent and cotangent go together like you think they would. But to me, cosine and cosecant seem like they would go together. They don't, right? There's two co's and one co. So therefore, cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So obviously, cosecant and secant have the same sign. They're both negative, but it's upside down. Good. 7. Take a look at the math playground on TikTok. Right? Nice explanation there. We'll come back to it if you have time. You want to do the law of cosines problem can become kind of it's just. Want to do it? We've done that recently.
One number.
You want to do some of that? That's number 8. That's just plugging numbers in there. Those numbers get not very nice. You know how to do that, but I think we should go ahead and do some of the. So I mean the trig identities, those should be. I mean, let's look at number. We'll come back to it. Let's look at number 9. 9. So number 9. So A for number 9 is what? Sine cubed of x plus cosine squared of x times sine of x. So just looking at that, you're asked to just simplify it, right? So tidy it up. I mean, is anything kind of screaming to you looking at that? What do you want to do? You got two terms. Well, see what there's two terms?
There's sine and there's cosine.
Well, yeah, kind of. But the terms are, if you multiply and jump together, it's one term.
Yeah.
So you have a sine cube. Sine cube means sine times sine times sine. Right? So sine of x times sine of x times sine of x. But then the plus or minus sign is going to separate your terms. So you have sine cubed, and here you have cosine squared, so cosine of x times cosine of x times sine of x. So if looking at that, I mean, there's a common factor in the two terms of sine of x, right? So a factor is something you're multiplying together. So if you just pull out a sine of x, which probably would be a good thing to do, and then see what happens. Right? Okay. Pull out a sine of x. You say sine of x times what is sine cubed of x?
Sine of x of
Okay.
x.
Sine of x of x.
You
Well,
said sine of
sine
x.
so I looked at this, I yanked out a sine of x. And then if you factor it, basically say sine of x times what gets you back to that first term, right?
Oh,
Because if you distribute it, you
Sine
should always
of
get
x
back to
squared.
where you started from. Yeah, sine, right? Sine times sine squared is sine cubed. Yeah, that's gonna be sine squared of x, and then you have sine of x times what is gonna be the second term? Obviously, cosine squared, right?
right.
Is that obvious? Should be obvious.
Yeah.
But it's not. All right, this is cosine squared times sine of x. So plus cosine squared. And then you've got, well, what is this? That's the identity, right? That's 1, right? So just sine of x times 1. So sine of x, yeah. So that cancels, that it becomes just 1. So sine of x.
Yep.
Oh, 10, so yeah, so better. So 10, you got, y'all see no here? I think so. So 10, we have cosine squared of theta. And then we have times the quantity 1 plus tangent squared of theta. So looking at that, well, you should always, I mean, whenever you're doing any problems, or you're trying to simplify trig expressions, I would always have like written down the main identity, right? And that is that sine squared plus cosine squared is 1. So if you look at that, I would always write down sine squared of x or of theta plus cosine squared of theta is equal to 1. And then you look at that and you say, well, a 1 plus tangent squared, what can you do? I mean, you can get all the other identities from this, right? So, well, if you divide everything by sine, well, then you're gonna have, that's gonna be a 1, then you have a cosine squared over sine, it's gonna be a cotangent, right? Well, I have a 1 plus tangent, right? So if I divide everything by cosine squared, well, you get the tangent squared right here, right? The sine squared over cosine squared is tangent squared, right? And then that becomes a 1, right? Because you divide everything, you can't divide 1, you can divide everything by whatever you divide by. You keep it equal. So dividing everything by cosine squared, you would get tangent squared plus 1 is equal to 1 over cosine squared, right? And what's 1 over cosine squared? Yeah, you can, right? So therefore, this whole thing just becomes secant squared, right? Right, because tangent squared plus 1, that's the same thing as 1 plus tangent squared, obviously, right? So that is secant squared, right? You can see that. So I wouldn't memorize those formulas, just memorize this, know that one. And then if you see something like a 1 plus tangent, just look and see what identity that is. That's secant squared. So therefore, this becomes cosine squared theta times secant squared theta, okay? Now, is that tidy? Well, you can definitely go further than this. What is secant, right? Typically, you want to like, if you see any identities, right, popping out at you, use those identities, and then typically make everything sines and cosines. That's not always going to, that's a typical way to work through these. So secant squared is just 1 over cosine, right? Well, then what happens? You get cosine squared theta times secant squared is 1 over cosine squared theta. What is cosine squared times 1 over cosine squared?
Cosecant, or not, the cosines cancel?
Okay, so you get
1.
it's fine. Yeah, any questions? Alright, trig equation, jump into some trig equations, let's leave that out there, that's a good one. This one we need to know, then you can't not extend at all. Let's see, what we got, number 11, we got 4 sine squared theta minus 3 is equal to 0. Okay? Solving that is like solving for the only variable we can solve for is theta. Let's find all solutions, right? So if this was an equation, that was like x, right? You would get x by itself, right? So you would add 3 to itself, right? And then you would divide by 4, and then you'd have sine squared. So you have sine of theta all squared, right? Square root. And you're home. So, see that? So, have you tried something? No. No. So, just, is that it all, Art? Let's do it
4
all.
of sine squared of theta,
Yeah.
or 4 sine squared of theta.
Minus 3 equals 0.
So you move the 3 over, so
Yeah.
4 sine squared of theta
Yeah.
equals 3.
Okay, yeah. And then, yeah, so,
Divided by 4.
yeah, so then, what, you do those all in one swoop, or, so sine squared theta is equal to
3,
3
and then,
over 4, right? Or-
and that's 2 moves, but
Okay, well, that's, yeah, that's, yeah, two moves, two moves, altogether.
you
Yeah.
got,
And then-
oh, what's this, oh, okay, I got you. So then the sine of 3/4, or not the sine squared, when you wanna, square root the other side?
So, yeah, sine squared means sine of theta all squared, so if you kill off the square, right,
Yeah.
you could just square both sides, yeah. And you get, so the square root of sine squared is just sine of theta. So you'd have sine of theta is equal to what?
Square root of 3 over 2.
Oh, yeah, that was 2 moves all in one, right? 'Cause you-
Yeah.
Uh-huh.
So then it's
And
what
then,
angle?
so what, so now, well, so now how do you solve for theta, right? So you want
Yeah,
the
what-
angle whose sine, right, is square root of 3 over 2. And if you just use your finger, so
Yeah.
you would say square root of 3 over 2, oh, there it is, right? It's this angle, right? Because that would be square, so what angle is that? 0.
That's, pi over 3.
Oh, I messed up, yeah, oh, I see, right here, I messed up.
How?
So remember, whenever you square both sides, you always have to account for the plus or minus, right, square root of that. So you get plus or minus, right? It's either plus or minus square root of 3 over 2.
But
So
it
that
is
counts for,
pi over 3, right?
so what angle, well, so square root of 3 over 2 is pi over 3, yeah, right? So, yes, so pi over 3 somewhere here, right? That's gonna give you the sine to be, so the y coordinate on the unit circle is square root of 3 over 2. But where else do you get square root of 3 over 2? Sine is also positive, right? Also, right?
Oh, so it'll be 2 pi over 3?
So it would be 1 pi, it would be 2 pi, or yes, 2 pi over 3 as well. But you could be negative, right? So the negatives are just going to be the same angles that have reference angles
So
of
it's pi over
3 in the other
plus
quadrants.
2k pi?
2k pi, yes, but because you can cover all the
Or
quadrants,
plus,
if you just go
k pi?
pi over 3 and then do a k pi, that's going to give you, so k pi means if you go pi, it gives you 180 degrees or pi radians, and gives you the angle here. So that's going to be 1 pi over 3, 2 pi over 3, 4 pi over 3, right? And then 5 pi over 3 is also 1, right? But if you just do k pi, you get pi over 3 and 4 pi over 3. And if you do 2 pi over 3 plus k pi, you get this one and this one.
Alright.
So you do k pi to get like the diagonal, right? Or you do this all 4
Yeah.
and do plus 2k pi. But if you just list theta to be equal to, I said pi over 3, pi over 3, plus, just, well, you could do 2k pi, or just do k pi. That's gonna give you all the angles here, here, and then going around forever. Boom, boom, boom. But you always miss these. So to get those, you have to do 2 pi over 3 plus k pi, right? And that's gonna be plus k pi. And that's gonna give you these forever, right? Yeah. Questions, right? I was gonna ask any questions from out there in the world, or not live, it should be live right now. It's live, right? Must be after. What time? That clock is way off. But it's getting close. I don't know. Phones, I don't know what time it is. Getting close. The clock here.
It's 3:32.
It's 3:32. People are staying. It's nice, right? That's nice. We run out of here. We're actually, the clock ends at 3:33, right? We can go way longer if you want to keep going. Well, what other ones, specific ones do you want to go?
I'm not sure.
Yeah, sure.
Number 7.
Number 7. That's the one we skipped, right?
Probably.
Yeah. That's the one we could do. Wanted to a lot. Someone else has questions. So, I can edit. We're going way long. It's an hour.